Alright, starting the recording.
Do you start it?
Yeah, it's starting.
Yeah.
Whenever you're ready.
Alright, so with ROS, as you guys know, the first thing you gotta do to run anything is run ROS core, right? I did it again. I've always done this in the demos. But yeah, so ROS core, and so start the master node. And so I'm just gonna be showing the gate task. So you go to where the gate task is, just run Python file for the gate task. And you'll see right now, start the state machine, and it's just in the idle state, right? And so this is the gate task. And so this right here is where it creates the state machine and runs it, right? And so you basically create a state machine with Smash, and then you open it and you just throw some states in it, right? And right now we're getting all the states from this library thing, basically a library that we made ourselves, called state. And you'll see up here, state comes from C Dragon states, which is just this over here that we made. And it just has a bunch of different similar states and stuff with parameters to adjust them for each task and current state. So you'll see in the first state, it's called idle. Just like when I was running over here, you'll see idle, and this is the result of it. So it's in idle, the result is not done, so it's going back to idle. So you'll see right here, it's called idle. It's the state type of wait topic. This is the topic for it, right? And then if it's done, it'll move on to depth PID enable, which is the next state. And then if it's not done, it'll just stay at idle, right? So any questions about topics right now before I actually start publishing and subscribing stuff to it?
What is topic exactly?
Let me find the actual state that it uses. Okay. So, how to explain this? So, topic is basically where each topic is basically where the data for something is, right? So, it's basically like a variable that different programs can use in ROS, right?
Yeah, it's somewhat like a global variable.
Global variable across different programs, right? Different nodes in ROS's case. And so, let me show you right here. So to change the value inside a topic, you would need to use a publisher. So you publish to it. You see, so if you look at this day right here, there's a publisher right here, and it publishes something. And then to read what's on a topic, you need a subscriber, right? And you'll see right here in this state. So let's go back to here. So idle is a state of wait for topic, right? Which is this right here. And what it does is basically it creates a subscriber, and then the topic right here is, you can see it's passed in to the state. So if you see right here, what's passed in is this topic called gate enable, right? It's just a string. Like the topic names are just strings. So create a subscriber of gate enabled of type bool, and then it has this callback, right? And so anytime something is changed in that topic, gate enable, this callback runs, right? You see, so self.enable callback, and then here's the function for that. And what it does is, well, I mean, you can do anything inside of that, right? And in this case, all it does is it changes this enabled variable into whatever gate enabled topic had in it, right? So it's type bool, so it's just going to be true or false. So you see it's originally set to false. So if someone publishes false to this topic, gate enabled, then it's just going to set false back into it. And if someone publishes true to it, then it's going to set true to it. And then in the state machines, then there's also this execute function, and you'll see in wait for topic, all it does is if it's true, it just resets every value and just sets it done. If it's false, it sets it to not done. And you'll see right now, if it's false, it's not done. So it's just going back to idle, as you saw over here. When it's not done, go back to idle. Any questions? Did that kind of explain the topic, what the topic does?
Yes.
Okay. So right now we're waiting for depth enabled to get a true, right? The gate enabled, not depth enabled. So originally that would be done through the master state machine, but right now we're only showing the gate state machine. So I'm gonna show you basically how we tested the logic by publishing our own values and subscribing. Well, mostly publishing, because subscribing will be done by the actual state machine. So if you do ROS topic pub, so this allows you to publish to any ROS topic that's currently active. So if I just press tab, you'll see all the current ROS topics, right? And you'll see right here this gate enabled. So we're just gonna type gate enabled. Alright, and then just auto tab to fill it out, and you'll see right now it says false. So if I do false, start publishing false to it, and you'll see nothing happens because I'm false. It just goes to not done and send it to idle. Now if I send true, you'll see it switched. You know what I'm gonna do? I'm actually gonna detach terminal, so we're gonna have it next to each other so you can actually see that happening. Okay, so yeah, we published true, and it went from idle into right now. You'll see it's in this dive gate depth, right? And so you'll see dive gate depth is right here. So it looks like it skipped this state right here, right? But this state just kind of executes once and is over, because all it does is publish true to this topic and just move on. You see it only has one transition. It doesn't have a not done, it only has a done. Let me go show you this state. So the state is published topic. So we go over here, find publish topic. There it is right here. And you'll see this one doesn't have a subscriber, it only has a publisher, right? And so you create the ROS publisher in a very similar way. So instead of ROS Pi subscriber, you do ROS Pi publisher, and then the topic, and you saw it before, just like before, we pass in the topic through as a parameter. So depth control PID enable, so that's the topic. And then for publisher, you don't need a callback, because you're the one changing the value inside the topic. You're not getting a new value or anything, right? So then in execute, you'll see it makes this Boolean flag a ROS message, right? Because you have to use different kind of variables when you publish. So it's a ROS message of Boolean, and then the data for that ROS message, it sets self.value, right? And if you see value is also passed in from over here, you'll see the value is true. So in this situation, value right here is true, and then it publishes flag, and then just returns done. So you see there's only one possible outcome, just like it shows over here, done. And so when it's done, it goes into gate depth enable, and you'll see that's where we're at right now. Let's see if I can move this over a little bit. Okay. So right now we're in gate depth, in dive gate depth, which is the third state, right? Any questions on the publishing state right here? Nope. Okay, then I'll continue. So then you see dive gate depth is from the state, change depth to target. So let's go see that. Change depth to target, so it's this one right here. And you'll see this one's a little bit longer. Okay, so you see the only parameter here is depth target. And so what we pass in is gate depth, and you'll see right here it's 18. Right? So make a subscriber for depth control. Right? So this is the current depth for it. This is what this topic holds. It's the current depth. Right? And then wait a minute. Oh, okay, this was all I'm looking for. I couldn't find this for a second. I was gonna say this needs a publisher, but I don't see it. Okay, so here it is. So to change the depth, we publish a value to this topic right here, depth control set point. And whatever depth we want it to go to, we publish to this topic. So you see right here, we have a subscriber. I don't think I mentioned this at the beginning, but don't worry about the reset subscriber. That's not something I have to worry about yet. But yeah, so we basically have one subscriber and one publisher, right? One for the current state and one for the set point, so where we want to go. So we have the depth callback, and you'll see the depth callback. All it does is set the current depth, so the message data, to a variable that we have called depth, and then depth received equals true, just letting it know that we have received the value and that the depth control state is working. And then in execute right here, so this is what runs when it's in that state. We'll print out some information that you can see right here, but it's moving too fast so I can't really see it. Let me see if I can just kind of scroll so you can see it. So see it says depth was received, false, because we don't have freaked out. I wonder if that would be a problem. Okay, so it's saying it's false, right? So it's basically saying that it hasn't received anything. That's because we don't have the sub working. Nothing's actually publishing the depth because we're not in the water, you know? So that's what that's gonna be the data that we fake, right? Through ROS topic pub. And so we said not to worry about reset. So if the depth has been received, if it has not been received, then not done, right? Obviously nothing happened if it hasn't received the depth. And then if it hasn't published anything yet, because you need to publish what value we need to go to, then it's also not done. And this is when it finally is published. Where does it publish, actually? Oh, yeah, right here. Okay, never mind. So right here, it'll publish the set point. And then when it finally is published and stuff, if it's close enough to the target, so you see self.depth, so the current depth target. So if it's close enough, and then within variance, and we can change this variance. So if it's close enough to what depth we want it to, it'll go to done, right? So let's have that right there. So if you remember, the target was 18, right? So if you do ROS topic pub, and then we'll see depth control and state. So remember, set point was what we published, so that's where we published the 18, and state is where we're currently at. Oops. So let's publish something that's not 18, right? So let's publish 10. If you look over here, you'll see that depth received is true now. Man, that's freaking out again. But it's still not done. And going back to dive gate depth. So it did receive something. it does think we're in the water now, even though we're not. But it's not where we need to be. And then, so let's publish 18 then. And you'll see it moves into the next state. Any questions for that one? Alright. So then continuing, you'll see right now it's in rotate the gate, and you'll see after dive gate, it was supposed to go to yaw PID enable, right? This is basically the same thing as depth PID enable, where it just published the true to a value and then just moved on. Right. So let's see right here. So yaw PID enable, state published the topic, and then this is the topic it published to, publish true to it. Once it's done, rotate the gate, and you'll see that's where we are right now. Okay, so we're on rotate gate. You'll see that rotate gate is type rotate yaw to absolute. So we basically have like a compass basically on it. Sub rotate. Oh, yeah, we have multiple rotate yaws. Okay, so rotate yaw to absolute. So to kind of speed things up, I'm kind of just going to explain what they do and not go through it line by line like I did for the previous ones. But rotate yaw absolute basically turns the submarine to set position, right? So the submarine, like that. Let me just mute that real quick. Alright. So the submarine can be facing from negative pi to pi in radians, right? So negative 180 degrees to 180 degrees. And so this just sets it to face a specific direction. As the comment says right here, it's towards an absolute rotation on the Earth, because it's the same no matter where you're at, like the orientation of it. Like 0 radians is always going to be pointing the same spot, same direction, no matter where on the Earth you are. And so we're at rotate the gate, so to absolute, and then you'll see what's passed in is the yaw target, so what direction we want to point to, right? So the direction is gate yaw 1, and you'll see right there, it's 1.57 radians, right? So similar in the depth one, in that there's a current yaw and then a current and a yaw set point. So this one's still the depth set point. Yeah. Control. So the depth set point, we're going to be publishing to the yaw control set point. Wait, no, not to the set point. The state, because the set point's being published by the actual state, right? Right. You see publisher. Yeah, the set point's being published to by the actual state execution part, right? And so it was 157, as you can see right there. So if we do so if the sub's facing like 1.30 or something like that, you'll see it's not done rotating. But then when we get to, and to show you that it doesn't have to be exact, right? Because we have that variance. So let's say 156 instead of 157, you'll see it still move on. Any questions? Alright. So moving on, so that was rotate to gate. You'll see once it's done, it goes to track gate, which is the next one. And then track gate wasn't really working because CV wasn't done. So I wonder if this is going to work at all. Let's go track object. So you'll see track gate goes is type track object, gate topic. So if you go up here, gate topic is basically a topic with like 3 different messages, I think.
Yeah, that looks right.
So the X, the Y, and the area it takes on the screen. Oh wait, no, okay, never mind. So yeah, gate X, gate Y, and then gate area on the screen. So let me see something real quick.
Hello.
I remember Ed wrote this, right? Too. And to try to make it more, what's the word? I guess neater. Okay. So you'll see right here, gate X, gate Y, and then gate area, right? And so track object is probably the most complicated state. So this is track object, right? And this is all the publishers and subscribers. And then you got the callback for the X, the callback for the Y, the callback for the area, the callback for the current yaw because it needs to align itself, the callback for the depth because once again it needs to align itself. And then this is its execute. And the execute looks kind of small, right? But I mean, it calls all these different functions as well. So it also needs to move forward, right? So I'm not gonna go over how it works exactly. I'll just explain. Where is it? Okay, here it is. So the done part. So if it's centered in the X direction, centered in the Y direction, and the object is close enough, so like the area is big enough on the screen, then it moves to done, right? And now, I'm trying to remember how close it is and what the center is exactly. I remember.
I believe center was X over 2 and Y over 2.
Yeah. But like, because it goes by pixels, right? So I'm trying to remember how many pixels the camera had.
That I don't remember.
Camera height, here is it. Okay, so we need to find camera height. There it is, okay. Okay, so 300 pixels in the Y direction, 400 pixels in the X direction.
Dude, they were so low, so you got them with the one tap.
Does it also have the area here? Area threshold, area high. That's not what I want to search.
No.
Because I really don't want to do the math right now for like the whole area.
Yeah, that's fine. Either way, we're going mostly over ROS today, right? In the
yeah, hopefully. That's all we.
Alright, I think you gave a good overview of how like the synchronous state machine, like master.py works by moving through the other states, right? within an individual state machine. So the one you used here was getTask.py, right?
Mhm.
So basically, after getTask.py
Oh,
does
this is-
all of its transitions,
like,
then it switches over to another Python node file, right?
Yeah, I wanted to get to the end so I can actually show that when it's done, it publishes something. So here's what I'm gonna do actually real quick. I'm gonna just comment out track state. Send this over to. Just copy it actually.
Oh yeah, just bypass it.
Yeah.
I know, right?
Oh, yeah. So yeah, it does freeze.
He saved the ghost. He actually doesn't make any money.
So let me just.
He barely makes 1,000 mistakes.
Okay, so we're back to idle. So we'll just speed through it real quick. Gate enable true. And then publish depth.
You know what? I could use this crosshair.
It's at 57, right? There it is. Okay. So now we're in rotate gate left.
Yeah.
So this one's similar to the rotate rotate gate. Yep, to absolute. Except this one's wait for convergence. So this one, instead of going to an absolute value, it turns a specific amount, right? So you'll see, and to make it more, yes, usable for other situations, you set in all of them, so it doesn't have to just be yaw. You can also use this for depth, right? And so yeah, so it makes it so it'll wait until yaw control state and yaw control set point get close enough to each other. Type float 64 because we can use it in other situations. We have to pass in what type of topic it is. Gate yaw offset, you'll see, is this right here. So this is how much it wants it to turn, right?
Right.
So
I think we said
That's me. That's
0.17. That's what, 1 degree?
yeah, I think that's what it is. So it's basically trying to turn 1 degree, right?
Yeah, times 5. So
To the
5
left because it's
degrees.
negative, right?
Yeah.
So
I hate crosshair.
so let me go. Let's go check that out.
You know what I see?
Wait for convergence. So this is it. You'll see topic name, data type.
Dimitri, since you're the newest to this, does it seem to make sense, or
They
does
bullied
anything
that.
seem kind of strange to you?
Bully the shit out of it. Kill that.
Well, it's not like I understand everything, but
The important thing is, do you kind of understand the logic of it, right? Because you'll learn how to like create publishers and subscribers and stuff as you go. But basically, do you understand like the logic of how ROS works?
yeah.
Okay, that's good.
Yeah.
Is this out of order right here? Actually, topic name, data type. Okay, target, yes, subscriber. Oh, okay. There's a topic before it,
We just
state before it that I forgot to mention. So this one it's another published topic,
I have no idea.
and all it does is publish the yaw offset, so how much you want to turn by. Wait a minute. Yeah. So how much you want to turn by to for the yaw, right? And so basically what it did is it grabbed the state, subtracted this value right here, and published it to set point. Do you want me to go show that real quick, or like in the topics, or does that make sense?
Yeah.
I'm gonna take that as no questions. So then this one just waits until it gets there.
You know,
So,
yeah.
Yeah, so is it done? So okay, so if the topic, the current spot, and the target is less than the variance, then increments timer. Hold on, what is Ed trying to do here?
I think he makes sure that you stay there for a certain amount of time. Because remember him saying when you were like,
Oh yeah, it drifts around and stuff. Yeah, you're
yeah,
right.
it's
You're right.
twice.
Yeah. Okay. I'm glad you talked to him about this because I've been wondering what's going on here. So yeah. So if it's within variance for a certain amount of time, you'll see. So within the variance, you'll start the timer, and then once the timer gets to the minimum time, then it'll be done, right? So then it'll move on. So let's see, we were at 1.57 earlier, right? So does anyone want to do what's the math of 1.57 minus 0.17 times 5?
That's minus 0.85, right?
That's
So 0.72.
So if you go to 0.72 then.
Did I do that wrong? Let's see. Calculator. Oh, 0.07.
0.017,
Yeah, yeah.
sorry, that's my bad.
No worries.
If you also look at it right here, you can see there's a target value right here, and it'll tell us what we need to go to. So 1.485. So we just completely passed it. So let's say like the thrusters were on like really high and stuff, and they overshot it, so it didn't stay there long enough.
What is rotate gate does?
Which one?
Okay.
Get left.
No, not gate left. We had the rotate gate. It's here. Yeah, where you.
Right, rotate to gate.
Yeah, what does it? Does it do?
So in the competition, we know where the gate is every single time, right? So its position is absolute. So what this one does is it doesn't check the current state, right? Where the current yaw is, where the sub is facing. It doesn't check that. It straight up just publishes where the gate should be, right? To absolute. Does that make sense? And this one, it's relative. So it's not publishing to this value. It's publishing the current state plus this value. And since this is negative, it's going to subtract, so it's turning left. Does that make sense?
Sorry, not really. Why we have rotate gate left and we don't have rotate gate right?
Oh, because so this is more into like the competition, the actual tasks and stuff. And so the gate was kind of split up into two parts. Where if you pass through the left side, it's like a smaller area. It's like so it's more difficult to get to, but you get more points.
Okay.
So we track the gate, get close to it, then turn a little bit left so we can try to get through the left side.
Okay. That's me.
Yeah. So that's more of like the actual competition task.
Mm-hmm.
Does that make sense? We probably should have gone over like what each task is before doing the demo, huh? Or like at least explained it better.
Maybe.
But does it make sense now?
Well, again, I can't say it's everything clear.
Yeah, but like you understand why we're turning left and not right
Yeah.
and all that. And you'll see we call it rotate gate left and stuff, but you can use these states to turn right as well. It's just that instead of negative right here, you'd have positive, right?
Mm-hmm.
And so you'll see once we get 485. And then you'll see the timer went off for a while, and then it changed to move gate forward.
Okay.
And so move gate forward is a timed state, right? And what it does, so let's go find move forward. It basically turns on the thrusters, the yaw PWM, so the yaw thrusters. So this situation will be all 4 of those thrusters, right? It'll turn them on to what's the maximum value it sets it to? Okay, so this is the what controls it. So forward thrust max. Let's find that. So 280. So remember we said plus or minus 300. You remember talking about that? So we only go up to 280 for this. I'll mute that one too. Okay, so let's go find move forward. So change forward thruster. So what this does, it slowly increases at 280, right? It doesn't set it to 280 right away. And then it's on a timer, so it should be done by now. So yeah. So it moves on to the next state, which is buoy depth, and this is another depth one. So you'll see the buoy depth is 5 times 12. So when the gate depth finally gets to 60.
So for certain task, you already have all this data. I mean, like a map of this task, right?
Yeah, because the course and stuff is already set, right? So we know at what depth everything's gonna be. If our code works correctly, we know where the sub should be and where it should be going next and stuff like that. Where to turn, kind of, to help it out. Yeah, and the computer vision there is to help line it up and adjust it and all that. So let me open another tab right now. This one we're gonna do something called ROS topic echo. Right? And what ROS topic echo is, it shows you what's being published to that topic, right? And so do task complete, and we're just gonna have that run for now, and then I'll explain what's going on there. So now we're at rotate to buoy, and see, since we know where the buoy is, just like where the gate was, we're doing rotate to absolute, right? And the buoy yaw is so 45 degrees, basically. Because we said 0.017 is 1 degree. So, and then if you see after rotate buoy, so I'll explain before I do it. After rotate buoy, we go to completed, right? And this one's going to publish a value, task complete. And then it's just going to send it back to idle. So if we ever need to rerun it again during testing and stuff, we can just start running it again and not have to close out of it and start again. So let's go do that. So this one's okay. Does anyone know what 45 times 0.017 is? Should I calculate that real quick?
I don't know, but yeah, I can do it real quick.
Alright, so it's
765.
I did 0.17 times 45 and I got 7.65. I'm like, wait a minute, that doesn't work out in radians.
Yeah, we make that mistake a lot.
So 0.765, and you'll see it went to idle. It looked like it went to idle right away, but it actually ran completed once. And you'll see over here that it outputted a true to task completed. And so when this happens, usually when true is outputted to task completed, the master state machine knows, oh, it finished the task, move on to the next step. And so that's it. Any questions?
If no one else has questions, I'll ask since it's something we're gonna work on in automation. When we do thruster, what do we call it? Thruster.py, thrusterboard.py. We're essentially going to be creating new functions that would be called. So it would be more like cdragonstates.py rather than a task Python file like getetask.py.
For the new thruster one?
I believe so.
What kind of functions do you plan on having?
Strafing, forward, backward, yaw left, yaw right.
Because those would be more callbacks, right? Not really their own functions. Like you would have to deal with those inside of callbacks.
I think so. Yeah, we still need callbacks because we need to do the feedback callback.
Yeah, but like the whole strafing part is gonna be its own topic, and you're gonna have to deal with like the motor values in a callback. So you wouldn't have your own strafing topic. Does that make sense?
Okay, so I follow you on like publishing individual thruster values to their own topics, since we'll be having 8 different motors. I follow you on the callback. So when we actually set it up, it's going to be called just like. Actually, do you mind going into one of the function calls for movement? Like I think on getTask.py there was the yaw relative one, right?
I mean, but yeah, I'll go real quick. But I was gonna say you're not really dealing with all that inside of the thruster stuff, right? Like you're doing the actual PWM values in the thruster one. So you're kind of gonna be subscribing from those, but I'll let you explain it and I'll see if. So what were you looking for in getTask.py?
Like the yaw set point.
What do you mean by yaw set point? Like rotate yaw to absolute, kind of?
I believe so. So we're still calling the cdragon state function, right?
No, not in the thruster one.
Sorry, in getTask. Like
In getTask, yeah. So from state, which is the cdragon states, as state, and then rotate yaw to absolute.
Yeah, so currently it's still using the cdragon state function, and that cdragon state function is only utilizing the 2 thrusters it thinks that.
No, not at all.
Okay.
This one just says what it needs to be and all that. And then it'll just, since it uses PID, you'll give it some feedback. And then the thruster driver one's the one that deals with the 2 motors and 3 motors and all that.
Oh, okay, that's my misassumption then. Do you mind going to that cdragon state function real quick?
It was, yeah, absolute, right? 2 absolute. So if you'll see, it doesn't have anything to do with multiple motors or anything.
self.yaw target equals yaw target received.
It's just its current state, so where it currently is, and then the set point. And then the PID package will give it a feedback value. And then the thruster driver handles the feedback value and the motors and decides what the motor should be depending on the feedback.
Right,
Does that make sense?
Conceptually, yes. Now I'm trying to figure out how it translates that to the PWM values.
So I can show you that real quick.
Okay.
This is the current stuff, the TZs, SRC, this one. So, yeah, so the Sea Dragon states you wouldn't change anything at all because they don't deal with thrusters and stuff, which is nice, right?
That's a good layer of abstraction.
And then, so that was yaw, right?
Yeah, yaw absolute, I believe.
Okay, so here's the layout. So just so you know, the names of the motors, M1, M2, M3, M4 is the depth ones, and then L thrust, R thrust is the yaw ones. So when dealing with the yaw, so like right now we're looking at the yaw, right? The yaw feedback specifically, which is this right here. So this is the yaw feedback callback.
Yep.
So remember, this is a callback. This comes from a subscriber, right?
Yeah, so that gets called, I believe, automatically, right?
Mm-hmm.
Okay.
So let me go see if I can find the subscriber real quick.
Oh, we only got one more.
So feedback callback. Okay, so this is the topic name, right? This is updated through the PID package. So we don't even need to worry about that. I mean, other than like the PID tuning that we do and all that, but actually when it updates it and all that, we don't need to worry about that because PID package is dealing with all that.
Okay.
And so the PID package will give us a value from 0 to 75.
Okay.
Does that make sense?
Yeah, so where 0 is like...
It's not on at all, and 75 is about as high as possible.
Alright, so for yaw, that translates to 0 to
Oh.
360 degrees?
No, this is the actual PWM value. So how the PWM for the motors. So right now we're not worrying about where it's looking and all that. Does that make sense? PID is going to look at where it is and where it needs to be, right? So the PID package is going to be looking at negative pi to pi, right? Looking where it needs to be and all that. And it's going to do all the math it wants to do with like the PID, the variables, the PID tuning, what we chose for each variable. It's going to do different. It's going to do all the math and decide, okay, it needs to be it's pretty close, so let's not turn it on too much. I'll probably maybe set like a 5, you know?
Okay, so...
But like looking at where it is and how far away it is and stuff and all that, the PID package is dealing with that.
Okay, so all it sends us back is the magnitude for the thrust.
Yeah, the magnitude, that's a good way of putting it.
Okay.
And then you decide how you want to deal with the magnitude.
Okay, so we handle all the positive, negative logic and notations.
Yeah, so right now we only have 2 thrusters on this one, right? So PWM baseline, you know, is 1500.
Oh, sorry, Marios, can you hear me?
Yeah, can you hear me?
Yeah, you cut out for like 2 seconds.
Okay. So I was just saying, so you know the PWM baseline with 0, you know, is 1500. So at 1500 is when the thrusters are off.
I like that. I actually really like this.
Right.
And then I'm not sure what's the point of all this, right? Since it already sets it to
Bottom of the barrel.
it already sets it to 1500 at the beginning. -1 greater than 0.25. I mean, okay, well, this is inside the if, and this is the feedback message data times negative. I'm not sure about what's the point of this, right? Because it already sets it to the baseline.
So if motors are not running, like if they're at the baseline, and if you have a
So
positive,
update it so it has to get a value greater than 0.25 from the topic. And then, so it just sets the feedback value, it just sets it to the message data as 29 for, because it's the T200, and then multiplies it by -1 since, and this one's not multiplied by -1 since, they need to be in opposite directions if they're going to turn. And this does the exact same thing except subtracts it since it's going the other way.
yeah, so one of them's
Oh,
turn left,
he
the
ran
other one's
into
turn
this.
right. Otherwise, set the feedbacks to 0.
Yeah. Still, it was funny.
And then, yeah, so if stuff, make sure the feedback's 0, so it doesn't want it to turn at all. And then it adds the feedback to the PWM baseline down here. So yeah, it's current PWM, adds feedback, and that's its total, and that's what's going to output to it. Right here.
Alright, and the
You see
part that you weren't sure on was the other else block,
Yeah.
where if it's not equal to baseline, right?
Mhm.
So if you're not at baseline, that means
So
motors
the motors are already on then, right?
That was a pretty good impression.
So it looks like the only difference is that it's not dealing with like the 29. Okay, that makes sense. Never mind.
Bro.
So if the motors are already on and stuff, then it already added or subtracted the 29 that it needed.
Yeah, the more I look at that, the more I think it really is just motor spin up,
Mm-hmm.
where it has that initial resistance it has to overcome.
Yeah.
What was it?
So if it already, because yeah. So if they're not at the baseline, then that means they're already on. And so if the motors are on, then you don't need to deal with plus or minus 29 around 1500. So yeah, no, I know that's fine.
Okay, cool.
So yeah, that's the yaw. And then so basically, with 4 motors, it's gonna be like left 1, left 2 feedback, right 1, right 2 feedback. And you're gonna have to make sure that they're all like the right values. So if like the front left and the back left are facing opposite directions of each other, but you still want them to go the same direction in terms of like the actual thrust. Like one of them would be negative, the other one would be positive. Then you need the left side and the right side to be the opposite. So if front left is negative, then front right's going to be positive.
If they challenge me, I'll challenge you back.
And then if back left is positive, then back right's going to be negative, and so on.
Yeah.
Does that make sense? So that's when we're actually have to start dealing with what direction the motors are facing and what way we want them to push and all that.
Yeah. So I guess in the case of yaw, the 2 left thrusters have the same orientation or not orientation, but the same like spin direction.
Yeah, you want the same spin direction, but if the motors have the opposite orientation, like we were talking about the other time, then that means they'll have to be the opposite in this case, right?
Yeah.
Because you want them to push the same direction.
Okay, that makes sense then. So essentially, when we take this and we convert it to the Python file, we're going to have the same names so that it works with the PID package.
They flashed each other.
And then
for the topic names, yeah. You can name the motor names whatever you want. It's just that in the Python one, since we're not outputting anything, we're not going to need this right here. Because this has to do with when it outputs it to the pin, right? And then, so that means you're not going to need these. And then, at the bottom right here, where it actually outputs it, so like when it outputs it to the pin, so this one, the pulse width.
We're going to create a new topic for that.
Yeah, instead of outputting to the pin and all that, you're going to have a publisher, you're going to publish the topic.
Alright.
But other than that, it should be pretty similar. It's just you're going to add 2 more motors to each callback, and then you're going to add 1 more callback for strafing.
And then all the necessary overhead for the Python file.
Mm-hmm.
Okay, that makes sense then.
But yeah, so a lot of it's going to be similar when it actually comes to the callback.
Cool. All right, Dimitri, did you get all that?
Yeah.
Far out.
I did try label image
Yeah,
at the time
yeah.
that we're doing the demo.
Okay. That's not a
It doesn't recognize it right now. It's possible because of WSL 1. So I'll try WSL 2 later, see if that works. If not, I'll just do like a Ubuntu virtual machine.
All right.
Also, Dimitri did ask before in the text channel, and I don't know if you
Ready for
answered it in
another
the voice
fight?
chat before I joined. When we finish the workloads, where do you want us to upload them?
The same folder that you got them from. Just make sure you label it so I know that it's finished.
Okay, and
So like I'm looking right here. So like Hubert just added the word labeled at the end. That's good. And then Dimitri just said done. Give me Dima flat. That's good. Except that they're all XML. So you said you'll adjust that, right, Dimitri?
Yeah, I will re-upload new one.
And do you know? Was it only like the yellow setting and stuff, or was there something else you needed to change? Because we might want to make a note of that if you had to change something else.
It's okay. It was my mistake. So.
Okay. So yeah. So it should work fine for everyone else then.
Delete my archive. This.
I don't know if I have permission to do it. Done, Dima flat. There we go. Okay.
Which repo are you guys looking at for changes? Because I'm not seeing any on. I'm not seeing it on the default repo.
What changes?
The labeling and whatnot.
It's in the drive. And just like where the data sets are and all that, we're just talking about like the finished ones and the not finished ones.
alright, I'm gonna stop the recording here then, since we're done with the demo.
All right.
okay.